Hello, this is Mrs. Sargent, and this is lesson 3.5, History of the Periodic Table and Metals, Nonmetals, Metalloids. Today we're going to talk about how the periodic table was organized, as well as how to classify elements into metals, nonmetals, and metalloids. So John Newlands, he developed the Law of Octaves, and that says that when elements were placed in order of increasing atomic mass, their properties repeat every eighth element. So if any of you are musical, in music there are octaves, and that refers to the groupings of musical notes. There's 8 notes, and then it repeats. So in the same way, when you organize the periodic table in increasing atomic mass, the properties are going to repeat every 8th element. Dmitri Mendeleev, he is known as the father of the periodic table, and he arranged the elements in order of increasing atomic mass. He predicted properties and left spaces for undiscovered elements. So down here at the bottom is a picture of his periodic table that he developed. And you can see that there are some spaces left in here. There's no element listed there and no mass, but they knew that, well, we're not going to put gold right next to bismuth, and so we left that space. Also, you can notice the question marks. They're pretty sure there's an element there, but not exactly sure what it is. And so they left those spaces knowing that there has to be something that fits in there, but we're not certain at this point in time. There also are elements that are named after people, and so element number 101, Mendeleevium, was named after Dmitri Mendeleev. Henry Moseley arranged the periodic table with the elements in order of increasing atomic number. And this is the current way that our periodic table is organized. Glenn Seaborg, he placed the lanthanide and actinide series at the bottom of the periodic table. So your F sublevel, the top row of the F sublevel is the lanthanide series, and the bottom row is the actinide series. He moved that down below the rest of the periodic table. And there is also an element named after Glenn Seaborg, number 106, Seaborgium. Periodic law states that this is the repetition of chemical and physical properties of elements when arranged by increasing atomic number. I think the lines for your closed notes on periodic law is a little messed up, so just make sure that you have this definition written down. So on the periodic table, we've discussed that the period numbers are the same as the row numbers. And so a period is a row, a horizontal row. As you go across a period, the properties change. A group is a vertical column, and the elements within that vertical column share similar chemical and physical properties. So here's how I remember the difference between a period and a group. As you write a sentence, you put a period at the end. You write left to right on a line on your notebook paper. So periods go from left to right. For columns, if you look at like the White House, there are large columns in front of the building, and they go vertically up and down. And so a column is going to be vertically up and down. Representative elements, those are groups 1A through 8A. And these representative elements exhibit a wide range of physical and chemical properties. So I told you that there are 3 different ways to classify elements into metals, nonmetals, and metalloids. Our first group, metals. Metals are lustrous, and lustrous means that they are shiny or glossy. So if you look at most metal, they have a sheen to it. It is glossy looking. Metals are also good conductors of heat and electricity. This is why a lot of our pots and pans are made out of metal, as well as why we use metal in the wires that we have for electrical equipment. Metals are solid at room temperature with the exception of mercury. Mercury is liquid at room temperature. Metals are also malleable, which means that they are flexible and can be pounded into sheets. They are also ductile, which means that they can be drawn into wire. And most metals have a high density and melting point or boiling point. So melting point goes for your solids, they would melt. Boiling point would go for liquid. The only exception to the high density and melting point would be gallium. Gallium metal melts at 80 degrees Celsius. And so this piece of gallium that's sitting in this guy's hand is actually melting with his body heat. Nonmetals are gases or brittle, dull solids. So if they're solid, they're going to be easy to break apart, and they're not going to be shiny or glossy like the metals. Nonmetals do not conduct heat or electricity, and they are not malleable or ductile. Nonmetals also have a low density and melting point or boiling point, with the exception of bromine. Bromine is liquid at room temperature. Metalloids are properties of metals and nonmetals. So they're kind of like the in-between, and they're brittle solids, and brittle just means that it's easy to break apart or to shatter. Metalloids are semiconductors. They're going to conduct some electricity, but not as well as metals. And you can see here in the picture, most of our metalloids are usually gray in color. On the next page, you have a periodic table. We are going to color the periodic table and show where the nonmetals, the metals, and the metalloids are at. So one thing I just want to point out is that on your page, metals is listed first, then nonmetals, and then metalloids. You can use the green, the blue, and the orange, or you can use any colors. You can use highlighters, you can use crayons, colored pencils, anything that you have just to distinguish between these 3 different groups. So in this picture, the metals are the green, the nonmetals are the orange, so everything up here plus hydrogen. And the metalloids, there is this stair step, which is just kind of a thicker line on your periodic table. It just looks like a set of stairs. So all of the metalloids sit on the stair steps plus germanium and antimony. So it might be easiest to color in the metalloids first. And then everything above the metalloids is nonmetals plus hydrogen. Everything below the metalloids are metals. So you can go ahead and color that, pause the video, color it, And then you're going to want to circle in red the two elements that are liquid at room temperature. Well, we said that bromine is liquid at room temperature, as well as mercury. And you can see on your periodic table it's a little bit lighter shade of gray. And so that is why mercury and bromine would be liquid. On here they're in blue. Your gases, remember we said a lot of the nonmetals are either gases or brittle solids. The red on here, the elements that have their symbols in red, are gases. So that's it for today's lesson. You have practice at the bottom of the page, a couple questions about organizing the periodic table as well as classifying metals, nonmetals, and metalloids, properties as well as different elements. So go ahead and make sure you get that caught up. Stop in and ask me if you have any questions. Thanks for stopping by. Have a great day.